We all wake up, live our lives, and go to sleep, completely oblivious to one monumental, ceaseless motion that defines our very existence. We never feel it, never consciously acknowledge it, but right now, every single one of us is hurtling through space at an astonishing speed. The Earth, our home, is spinning. It's an invisible dance, a cosmic waltz that dictates day and night, shapes our weather, and quite literally holds everything together. But what if, for just one single terrifying second, that dance stopped? What if the Earth, in its majestic ancient rotation, simply paused? It's a thought experiment that sounds almost whimsical, doesn't it? A momentary glitch in the cosmic machine. We imagine this serene, quiet, perhaps a moment of calm before everything restarts. But the reality, the scientific reality, is far, far more brutal. It's a scenario that would unleash a level of chaos and destruction so profound, so instantaneous, that it beggars belief. You see, we're not just standing still on a stationary planet. We are, right now, moving at an incredible pace along with the ground beneath our feet, the air we breathe, and the oceans that surround us. At the equator, this speed is roughly 1,037 miles per hour. That's faster than the speed of sound. Even here, at more moderate latitudes, we're still moving hundreds of miles per hour. We don't feel this speed because everything else around us, everything within our immediate environment, the buildings, the trees, the very atmosphere, is moving with us in perfect synchronicity. It's like being on a perfectly smooth, enclosed train. You don't feel the speed until the train suddenly, violently stops. And that's the crucial point. If the Earth were to suddenly halt its rotation, even for just a second, the planet itself would stop. But times we wouldn't asterisk. The atmosphere wouldn't. The oceans wouldn't. Every single object, every living creature, every drop of water, every gust of air would retain that incredible eastward momentum. It's a fundamental principle of physics, one you've experienced every time your car brakes sharply, throwing you forward. But imagine that car is moving at over 1,000 miles an hour and then hits an invisible wall. The implications are immediate, widespread, and apocalyptic. This isn't about the Earth shifting on its axis or changing its orbit around the sun. This is about everything on its surface suddenly being detached from its momentum. It's about kinetic energy on a planetary scale, suddenly needing somewhere to go. So, let's peel back the layers of this terrifying thought. Let's really consider what that single, fleeting second of planetary stillness would mean for life as we know it. And for life, times after times it. Because that 1 second would reshape our world in ways that are almost impossible to fully comprehend. It would be a cataclysmic, universe-shattering event, all compressed into the blink of an eye. The sheer scale of the forces unleashed would be beyond anything humanity has ever witnessed or even conceived. To truly grasp the horror of it, we first need to appreciate the silent ballet our planet performs every moment of every day. Earth isn't just a big rock in space. It's a dynamic, spinning top. It completes one full rotation on its axis, approximately every 23 hours, 56 minutes, and 4 seconds, what we call a sidereal day. This rotation is what gives us our day and night cycle, warming and cooling different parts of the planet, driving atmospheric circulation, and shaping ocean currents. It's a fundamental rhythm of our world, but that speed isn't uniform. The rotational speed is greatest at the equator, gradually decreasing as you move towards the poles. If you're standing on the equator, you're traveling at roughly 1,670 kilometers per hour, or about 1,037 miles per hour. If you're the North or South Pole, you're effectively just spinning in place, covering very little linear distance per unit of time. Most of us are somewhere in between, still moving at considerable speeds, often hundreds of miles per hour. Now, why don't we feel this incredible speed? Why aren't we constantly being flung off the planet? The answer lies in something called inertia. Simply put, inertia is the tendency of an object to resist changes in its state of motion. If an object is at rest, it wants to stay at rest. If it's in motion, it wants to stay in motion, at the same speed and in the same direction, unless acted upon by an external force. In our case, everything on Earth, you, me, buildings, cars, oceans, the very air, shares the same rotational motion as the planet itself. We're all moving together. There's no external force constantly pushing or pulling us relative to the Earth's surface because we times are times part of the Earth's surface. It's a common frame of reference. This is why when you're on an airplane flying at 500 miles per hour, you can still walk down the aisle, pour a drink, and feel completely stationary relative to the plane. You're moving with the plane. But what happens when that shared frame of reference abruptly changes? That's where the catastrophe begins. The moment the Earth's solid crust, its mantle, its core, asterisk stops times for that single second. Everything times, not times fused to its bedrock, would continue its eastward trajectory at whatever speed it was previously moving. Imagine the atmosphere itself. It's not static, it's a fluid, clinging to the Earth through gravity, but still subject to inertia. If the Earth suddenly ceased its rotation, the air, still moving at over 1,000 miles per hour at the equator, would continue to rush eastward. This wouldn't be a hurricane, it would be a supersonic blast. Think of it as a global, instant, super tsunami of air racing across the surface of the planet. These winds, moving at speeds greater than bullets, would scour the land clean, stripping away soil, vegetation, and any unanchored structures. Buildings would be instantly flattened, not just by pressure, but by the sheer kinetic force of the air molecules slamming into them. Cities would be annihilated, reduced to rubble and dust in mere moments. No living thing on the surface would survive this atmospheric shockwave. Then consider the oceans. They are vast, interconnected bodies of water, also possessing immense inertia. As the solid Earth beneath them grinds to a halt, the oceans would not. They would continue their eastward motion, piling up against the continents with unimaginable force. We're not talking about a 50-foot tsunami here, or even a 500-foot one. This would be a wall of water, hundreds, perhaps thousands of feet high, sweeping across continents. Coastal areas would be obliterated, but the devastation wouldn't stop there. This colossal wave would surge inland for hundreds, even thousands of miles, drowning everything in its path. Entire land masses would be submerged, scoured clean by the sheer volume and velocity of water. The friction generated by this moving water against the suddenly stationary seafloor would also create immense heat, further contributing to the chaotic energy release. And what about everything else? Every car, every train, every airplane in the sky, every human, every animal, every tree, every unrooted rock, every building not literally bolted to the planet's core would be instantly launched eastward. Imagine standing on a giant spinning carousel that abruptly jams to a halt. You'd be flung off, right? Now, scale that up to a planetary level. With speeds exceeding that of a jet fighter, people would be thrown from the ground, launched eastward at hundreds of miles per hour, tumbling uncontrollably. The impact with any surviving obstacle, or simply with the ground after being airborne, would be instantly fatal. Concrete and steel structures, designed to withstand vertical loads and modest horizontal stresses, would be ripped apart, their foundations unable to hold against the immense shear forces. They would essentially be sheared off their bases and flung eastward, collapsing into a deadly torrent of debris. Trees would be snapped like twigs, their trunks unable to withstand the sudden lateral acceleration. Rocks would be dislodged, creating a planetary-scale landslide event. The Earth's crust itself, while largely solid, isn't a single, rigid block. It's composed of tectonic plates. A sudden, instantaneous stop of the entire planet would induce colossal internal stresses. The friction and strain between the mantle and the crust would be immense. We're talking about earthquakes of an unprecedented magnitude, far exceeding anything ever recorded. These wouldn't be localized tremors. They would be planet-spanning seismic events, tearing apart continents, opening vast fissures, and triggering volcanic eruptions on a global scale. The sheer amount of energy dissipated in this single second of deceleration would be equivalent to countless atomic bombs detonating simultaneously. But let's not forget the slingshot effect. For objects near the equator, moving at over 1,000 miles per hour, that sudden stop would effectively be like being launched from a giant catapult. Depending on their exact speed and latitude, some objects, particularly those airborne or less anchored, could even achieve escape velocity, or at least be propelled high into the upper atmosphere, only to fall back down as superheated, fragmented projectiles. The friction of everything moving so rapidly against everything else would also generate an incredible amount of heat. potentially igniting fires on an epic scale, adding to the immediate inferno that would engulf the planet's surface. So, for that one terrifying second, the Earth would experience an unimaginable spasm of destruction. Every system, every delicate balance would be violently disrupted. The planet would effectively be flayed, scoured, and torn apart. But then, as our hypothetical scenario states, after that single second, the Earth would resume its rotation. What would be left? The immediate aftermath would be a landscape of unimaginable devastation. The oceans, having surged eastward, would then rebound, crashing back across the continents, creating even more catastrophic tsunamis in the opposite direction. This oscillating motion of water and air would continue for an extended period, creating a chaotic environment of perpetual, super-violent storms and floods. The atmosphere, having been violently displaced, would take a long time to restabilize. For weeks, months, perhaps even years, the planet would be racked by supersonic winds, constantly shifting, carving new channels in the ruined landscape. The air would be thick with dust, ash, and water vapor, blocking out the sun and plunging the planet into a perpetual twilight. Photosynthesis would largely cease, leading to a collapse of any remaining food chains. The geological scars would be profound. The massive earthquakes would have reshaped continents, creating new mountain ranges, vast valleys, and unprecedented volcanic activity. Magma would flow freely from newly formed fissures, and the air would be choked with volcanic ash and gases, further contributing to a long-term climate catastrophe. The Earth's magnetic field might even be temporarily disrupted or weakened by the internal stresses, exposing any remaining life to dangerous solar radiation. Any life that managed to survive the initial impact, perhaps deep-sea creatures or organisms buried far underground, would emerge into a world utterly transformed and hostile. The surface would be an uninhabitable wasteland, devoid of vegetation, scoured clean by wind and water. The global ecosystem would have suffered a mass extinction event of unparalleled scale. The very composition of the atmosphere, altered by volcanic outgassing and the absence of plant life, would be radically different. Even the planet's orbit around the Sun, while not directly affected in its primary velocity by a second of axial rotation stoppage, would be experiencing a subtly different gravitational pull from a planet whose mass distribution had been dramatically, violently reconfigured. The new equilibrium of the oceans and atmosphere would create a new kind of weather system, perpetually extreme and unpredictable. This thought experiment, as horrific as it is, serves as a powerful reminder of the incredible forces at play in our universe and the delicate balance that allows life to flourish on Earth. Our planet's rotation isn't just a casual spin. It's an integral part of a complex system that makes our existence possible. It's a testament to the sheer power contained within our seemingly placid world. The Earth is robust, incredibly so, but it operates within a precise set of physical laws. Deviate from those laws, even for a single, fleeting second, and the consequences are nothing short of cataclysmic. It underscores our profound dependence on the silent, ceaseless motion of the world beneath our feet, a motion we take for granted every single day.